Let's see. There we go. Okay. So we talked about our tangent function. So we know that the tangent of an angle is always the ratio that we get when we divide the opposite side, or the side opposite from the angle we're looking at, by the side adjacent. Okay? So there are two other functions that we use because we don't always know the opposite and the adjacent. Okay? So, this is great when you're looking at a right triangle and you know this is 32 degrees right here, and you know either the opposite or the adjacent, like this, and you're looking for either the opposite or the adjacent. So yeah, tangent function, we're good, right? Okay, so then that's not always the case. So we've got this now, okay, and this time, well, I know this is 32 degrees again, but this is 10, and I don't want to know this side. I want to know this side. So I want to know y right there, or I want to know the hypotenuse. Well, tangent's not going to do it. I take it back. It will do it, but only in a roundabout way. Because if I figured out what x was, could I then use the Pythagorean theorem to find the hypotenuse? Okay. Well, we're way too lazy for that, aren't we? Okay, that's right. So we want a different function. So I suppose, thinking about it, I guess we could just use the tangent function all the time and then use the Pythagorean theorem. Well, no, maybe not. I'll get back to that. Okay, so here, looking at the angle that I have right there, what's the 10? Which side is the 10? Is it the opposite, the adjacent, or the hypotenuse? Now, I know you want to say it's the short leg, but when we're doing trig, we always want to think about the side. Is it the opposite side, is it the adjacent side, or is it the hypotenuse? So what's the 10 in this case? Opposite side, and the y? The hypotenuse. So, okay, so every time I see opposite and hypotenuse, I think of the sine. So the sine of an angle is equal to the opposite over the hypotenuse. Now, it works exactly the same as the tangent function. Okay? We solve it the same, everything's the same. We just have to understand that we got to use the sine function when we're talking about opposite and hypotenuse. So in this case, we would say, well, the sine of 32 degrees is equal to 10 over y, which we can solve, can't we? Can we solve this for y? Okay. What does y equal then? Say it loud. Yep. 10 divided by the sine of 32 degrees, which we can do. We can ask our calculator. 10 divided by the sine of 32. And it says it's about 18.87. So this is 18.87. Now I gave you a trig sheet, a trigonometric functions sheet. I want you guys to come over here on the angle side, go down to 32 degrees, and just over to the right 1, which is underneath the sine column. So we're under the sine column, and we're here at 32 degrees. And what is the sine of 32 degrees? It's 0.5299 approximately. That's rounded off to 4 decimals. So all your calculator is doing is taking 10 and dividing it by 0.5299. Okay, so notice 10 divided by 0.5299. Nearly the same thing. Not quite. Why when I divide it by the sine of 32, is it not exactly the same as when I divide by 0.5299?
When you divide by sine 32, it's more precise.
Okay, that's exactly right. So 0.5299 is not exactly what the sine of 32 degrees is, but it's pretty close. And you'll notice our answer, it's still 18.87 when we round it off, isn't it? Okay, to 2 decimals. So it's close enough. So if you wanted to, you could use these trig tables to figure out missing angles and everything, as long as all your angles are whole number angles. What would happen if the angle was 32.5 degrees? I guess we could kind of go halfway in between here, right? What if it's 49.856 degrees, right? So back in the old days, you would have this, but instead of just 0 degrees, 1 degree, 2 degrees, it would be 0 degrees, 0.0001 degrees, 0.0002 degrees, and would go all the way down to 0.8999 degrees. And it would be like 20 pages of tables in the back of your math book. And you'd look that up, and then you get out your slide ruler, and fortunately, I'm way too young for that. I don't even know how to work a slide ruler. I just ask my calculator, but that's all it's doing, okay? So there you go. All right, so there's one more we haven't talked about. What is it? Cosine. Yeah, don't call it cos. I'll have to, there will be repercussions. Yep, right triangle trigonometry, that's correct. Okay, so this time I've got, this one up here is 63 degrees. And let's see, I know the hypotenuse is 18, but I want to know this side. Now, before I said we could always use tangent and then use Pythagorean theorem, but in this case, could we use the tangent? No, because we don't know the opposite or the adjacent, do we? Okay, so you can't always just use the tangent and then use the Pythagorean theorem to work your way around. Okay, in a case like this, we have to use the cosine, and the cosine of an angle is defined as the adjacent side divided by the hypotenuse. So tangent's opposite over adjacent, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So in our case here, the cosine of this angle, 63 degrees, is equal to the adjacent side. So there's two sides you might be able to say are adjacent, the x and the 18. Y'all see that? They're both technically, I guess, adjacent to 63. But the 18 is the hypotenuse. The hypotenuse is not the adjacent side. Do you understand? Okay, so this is the adjacent side, x, and 18 is the hypotenuse. And I think we can solve this one for x fairly easily. All we have to do is multiply both sides by 18. Okay, so get out your trig table, look up cosine look up 63 degrees. Oh, I didn't do all of it. Did I not do all the degree things for you? Oh, on the other side, okay. So find 60 degrees on the right hand side, go across to cosine 0.866. Isn't that? Is that what you guys getting? It's 0.4339. Is that what it is? 60 degrees?
0.8.
Oh, 63. No, that's not the way we read it. Here. Here's the cosine of 63 degrees, 0.45. Yeah, that's the same as, it's the same as the sine of 27. The cosine and the sine are inverse functions. I got to get a different table that shows you. You might have to write this one out. Anyway, all your calculator's doing is taking 18 times that number right there. Okay? So when you say 18 cosine 63, your calculator's just taking the cosine of 63 degrees, which is 0.545399, and multiplying it by 18, and it comes out to be about 8.17. So 8.17. Now what if I want to know this other side here? We could do a couple different things. Can you tell me one thing we could do? What? We could do tangent. Okay? Now, I wouldn't do tangent. Okay? And I'll tell you why in a minute. What's another thing we could do? Pythagorean theorem. Pythagorean theorem. 8.17 squared, y squared. Okay? I wouldn't use the Pythagorean theorem either. What else could we do? Okay, we could use the sine. We could say the sine of 63 degrees equals the opposite over the hypotenuse. And then we could find it that way. That's the way I would do it. Okay? And here's why. What if you messed up and got that wrong? If you use the Pythagorean theorem, this is going to be wrong, isn't it? If you use the tangent function, that's going to be wrong. Okay? So my suggestion to you is, if you cannot use something you figured out to figure out something else, you're more likely to get it right, because if you do one thing wrong, then everything else after that's going to be wrong too, isn't it? Plus, did we round that off? So the next thing so this is accurate to 2 decimals. If we use that to find y, then y will only be accurate to 1 decimal. So if you need y to 2 decimals, you're going to have to round this one off to 3 decimals and use that to find y. Okay, so I mean, it'll still work, but I would use stuff that you're given to find what you're looking for. So yesterday, Tyler said a word. It wasn't a 4-letter word. It was worse. What was that word, Tyler? SOHCAHTOA. What the heck is that? You might want to write that down. I think you could say many, many 4-letter words and people wouldn't even bat an eye. But if you say the word SOHCAHTOA to a bunch of adults, you will see a lot of bad faces pull. And they may slap you. I'm not sure. So what do you think this stands for? Sine? Opposite over hypotenuse? Adjacent over hypotenuse? Tangent? There you go. Okay? And I don't know how long this has been around, but I know I was taught it in high school, and I know that my teacher was taught it when he was in high school, and his was probably taught it when he was in high school. So it's been around for a long time. Okay, so what haven't we talked about now? So
on the table, there's sine, cosine, and tangent, and then there's 3 other.
yeah, there's the cotangent, the secant, and the cosecant. So we may get to those, we may not. Okay. So here, 65, 63, 16. What's the measure of this angle right here? I haven't asked you one time to find the measure of a missing angle. Okay? So we're gonna look at that right now. So, oh goodness. If I knew that, what function does that make you think of? Tangent. The tangent of this angle right here, x, what would it equal? 16 over 63. Okay. Now, what are you thinking of now? Cosine? Sine? Everyone make up your mind. Okay, sine. The sine of angle x equals the opposite over the hypotenuse. Okay? And then if I cover up the 16, now what do you think of? Now cosine. The cosine of angle x is equal to the adjacent over the hypotenuse. And it doesn't matter which one of these you use in this case, we're going to be able to find angle x. But here's the thing. You don't know, you rarely know all three. I mean, it's more likely you're going to know two of these. You could use the Pythagorean theorem to find the other one, but you just kind of go with what you know and say, oh, well, that's cosine, adjacent and hypotenuse. Oh, that's sine, opposite and hypotenuse. Oh, that's tangent. Okay? But the question is now, how do we find the angle? So I want everyone, get out your calculator, divide 16 by 63. So I get the tangent of angle x equals 0.253, well, 25, if I round it off to 4 decimals, I get 40. Don't you agree? Okay. So there it is. Okay, now get out your trig sheet. Go to the tangent column. Go down the column and find 0.2540. You find it? Okay, so there's not an exact angle for that, is there? There's no 0.2540 because this angle is not a whole number. But everybody find the closest one. It's somewhere between 0.23309 and 0.2493. So isn't it somewhere between 13 and 14 degrees? Everyone seeing it? Oh, sorry. Am I in the wrong place? Right here between 14 and 15? Okay. All right. Okay, so now do 16 divided by 65. So that's sine. So 0.246. Now go to the sine column. Go down to 0.246. Where are you? Isn't it somewhere between 14 and 15 degrees? Yeah. And guess what? If you do 63 divided by 65, which is nearly 1.9692, and you go to the cosine column, 0.9692, well, gosh, that's somewhere between 14 and 15 degrees, isn't it? Okay? So it wouldn't matter how we do this. It's going to work no matter what. Now, here's the thing. We have calculators. We're not going to be using this trig table. Okay? I just wanted you to see what's going on with that. We need to be able to find, our angle here. So here's the thing. If I take the tangent of that angle, it'll give me this number. Well, I've got the number, and I want to go backward and find the angle now. Okay? So here's what I do. Watch carefully. You watching? Second function, tangent. See how it gives me tangent to the -1 power? That's the inverse tangent. It's the opposite of the tangent, kind of, right? Okay? And I type in 16 divided by 63. And I don't believe you need to hit this end parenthesis. We'll make sure here. So it looks like that, and we hit enter, and hey, it gave me an angle somewhere between 14 and 15. Do you think that's probably right? Yeah. Okay, and so if you hit the second function, so inverse tangent, 16 divided by 63. So if you hit the end parenthesis or not, it doesn't matter. Okay, so let's try the sine one. Everybody try this. So how are you going to do this using the sine? What do you hit first? Second function. So the inverse sine of 16 divided by 65, 14.25. You getting it? Okay. Or inverse cosine of 63 divided by 65, 14.25. So whenever you're looking for the angle, what are you going to hit first? Second function. Okay, so we're going to do the inverse of the operation. Okay. So if I do the tangent of 14.25, it'll give me this number. If I do the inverse tangent of this number, it'll give me the angle 14.25. Okay? So, here. Okay, so here's the thing. Everybody on Creek's side of the room, I want you to find this angle right here, angle X. Okay? Everybody on Brooklyn's side of the room, I want you to find this angle up here, angle Y. Don't just do it on the calculator. Write it down, write out the function, then get out your calculator and figure it out. What function is everybody thinking?
Inverse.
Everybody? Everyone's thinking tangent. Even on both sides of the room. Okay. So it doesn't matter if we're looking at angle X or angle Y, we're looking at the opposite and the adjacent, aren't we? Are you in
I'm not sure how to get rid of it because I used a different calculator yesterday.
oh, so you're in radians? Is that what you're saying?
Yeah.
So on your mode right here, you hit mode, it come right down. Normal floating radian degrees. See right here where it says radians? See how you're in radians? That's in black. Just come down and go over to degrees and hit enter. And so that you're in degrees, and then you're good to go. Okay, Creek side of the room. How'd you do it?
Inverse tangent.
Okay, so the tangent of X equals, running out of juice on that one. Let's try another one. The tangent of angle X equals what? 12 over 21. Okay. And then you got out your calculator, and you said inverse tangent of 12 divided by 21, and you got 29.74. Yes?
Yes.
Okay, Brooklyn's side of the room. What'd you do? Brooklyn's side's quiet. Come on. Say it loud. Okay, so the tangent of angle Y is 21 divided by 12. So it's still tangent, But do you see how the opposite and adjacent switch depending on which angle we're looking at? Everyone getting this idea? Okay, so when I look at angle X, 12's the opposite. When I look at angle Y, 21 is the opposite. So they change depending on which angle we're looking at. The hypotenuse, though, it's always the hypotenuse. Got it? Okay, so here, if we do, well, heck, isn't the other angle 90 subtract that much? So if I just subtract 90, of course it won't be negative, but we should get 60.56, shouldn't we?
Or you can do the answer plus the inverse tangent.
Yeah. So I just want to make sure that we get the same thing here. So the inverse tangent of 21/12 60.26, isn't it? And it has to be. Now, if I were actually looking for both of these angles, do you think I would use the tangent function on both of them? No. I know I said don't use something to figure out something else, but there's got to come a point where you hope you're right. So I would figure out one of them, and then I would just subtract it from 90, and that's got to be the other angle. I mean, that's the corollary to the triangle sum theorem, isn't it? In a right triangle, the sum of the two adjacent opposite angles here is 90 degrees. So there we go. Okay, new contest. Creek against Brooklyn again. Creek's like, I'm going to destroy you, Brooklyn. Gotta be competitive. All right, angle A, angle B. This is 20, and this one is 18. Go. So Creek's finding angle A, Brooklyn's finding angle B. Straight to the calculators, guys. Write it down. Easton? Dang it. You guys are driving me to drink. So I'm not letting you off the hook this time. I'm calling on somebody. Be ready. Okay, Creek side of the room. Let's see. You're looking for angle A. So I hope that you looked at this and thought of a particular function. Rhett, what function did you think of? Cosine 1. Heck yeah! All right, so the cosine 1, the cosine of angle A equals the adjacent over the hypotenuse. So since they're looking for angle A, 18's the adjacent, 20's the hypotenuse, you have to use the cosine, don't you? Okay? So you write this down, then you get out your calculator, and you're just like, hey calculator, what is the inverse cosine of 18/20? And it tells you the measure of angle A is 25.84. Are we good? Okay. Now, if I wanted the other one at this point, I could just subtract it from 90. And the other one's got to be 64.26. 1/6, okay? But if we were finding it directly, Brooklyn's side of the room, we look at our problem, we think about finding angle B right here, right? What function do you think of? Ansley? Sine. Heck yeah. The sine of angle B is equal to the opposite side over the hypotenuse. So I just wanted you guys to see, both of these, we're using 18/20, aren't we? Okay? But the sine and the cosine are inverses of one another. It's like if you look at the sine of 0 and the cosine of the sine of 0 and then the cosine of 90, they're the same thing. And then once you get to 45 degrees, the sine and the cosine are the same number. And then as they separate again, so they just kind of work opposite for one another. We looked at the tangent yesterday. The tangent of 1 is a very small number, and then what happens to the tangent as we get closer to 90 degrees? Yeah, it goes to infinity, doesn't it? Okay, so the tangent just gets bigger and bigger and bigger. So let's see if this actually works. The inverse sine of 18/20 is it 64.16 degrees? Heck yeah, it is, right? So make sure you say the measure of angle B equals 64.16 degrees. Okay? Make sure you do things right. So there you go. When do you use the inverse function? There you go. Okay. So, assignment today.